My name is Gary Lesoing. I'm an extension educator from the University of Nebraska. What we have here is a tabletop rainfall simulator. You receive that from Conservation Demonstration. Bud Davis out of Salina, Kansas sell these. We have a jumbo version over there we'll show you a little later. Now just the tabletop version. We have different treatments here, soil samples that we've taken. These were taken out here in the area on the South Farm here in Missouri. This one has no vegetation growing on it, so it's just a bare soil. This is a similar soil to this. It's a Mexico soil. This had a cover crop weeds growing on it, but there was a lot of root structure in this growing. And these two samples were actually taken up in Nebraska. This is a 25-year continuous no-till soil out of bottomland. Kennebec soil was but it's pretty well saturated because they received probably 10-15 inches of rain this spring. This is prairie soil, but it's pretty much prairie sod for over 100 years. It hasn't been just torn up or tilled for over 100 years. We're looking at here. We've already ran these and looking at the runoff coming through and all what's infiltrated. What's going through here, we're going to show what's going through this prairie soil. After we pour the water on, this is actually about the 7th inch of rain this has received today. So we're going to see how much runoff and how much is infiltrated in the soil. This demonstration of a rainfall, and this is after saturated soil and receiving significant amounts. So very little of this is infiltration, although some of this is infiltration. And you see what's run off. You see the water's very clear, so there's no loss of soil erosion in the runoff. And this is after probably about 7 inches of rain that we see coming through here. These other, this is fairly clear as well. This is no-till, and but this had a lot of root growing in it, so it was kind of like a cover crop growing in this to have a lot of infiltration. There's more infiltration in this than actual the no-till, where no crops were growing for several months, and it's fairly clear as well. But here, this is by far the most. There's sediment in the bottom. Hardly anything is infiltrated in there, and this when we pour the water in there, like an inch of water, we're measuring, underneath here. You look here, you see all that water is infiltrated in here. I mean, there's been some runoff each time, but a significant amount has been infiltrated in the soil, even because we have the roots in the soil. And this actually shows a demonstration of the roots type things, live roots growing in there, which helps out. But what doesn't go is runoff. And like with this one, it shows there's some sediment in it as well. So this kind of demonstrates when you have tillage, and have bare soil. It's going to run off if you have a rain, and it's kind of seal the soil. Whether it's no-till and you have roots growing, that's going to be a condition where more of it's going to infiltrate into the soil compared to when you don't have any roots and you have bare soil there, and the structure's not nearly as good. This is something you can definitely do it and set it up pretty fast inside, and taking the sample. It's easier to take a sample with a smaller a cutter. Regard to that, it's fairly small. The jumbo is much larger, and getting it to hold together and stay, it takes a lot more effort to get that done. This works very well for a classroom setting as well. You could set it up like we are here inside a lab, or in a room, just so you got a table to set it on, and instruments and utensils to pour the samples into. So, well, this is a jumbo unit, rainfall simulator, and we're just going to show you, how it works. We have two samples here. One is a native prairie, about 15-20 years it's been in prairie. These are from northeast Nebraska, a research station up there. This is cropland. It's kind of conservation tillage. There's been a little bit of tillage on this soil, but it's been pretty well saturated. We ran about 6 or 7 inches on it already. But the first time we ran that, there was no runoff at all went into the soil. in this prairie soil. And then, you know, like I said, it's 15, 20 years in this soil, and roots go down several feet. So Todd and I will put another inch on, and we'll see what happens. The runoff and the infiltrates. You see it's running off already. There is some erosion. Some of the soil has pretty good cover on here, but now you can see there's some soil running off. But other than this soil on the top running off, the soil is pretty clear. And you see off the prairie soil, it's all very clear.
Yeah, the big thing that we are illustrating tonight is that we do have a significant difference between the total amount of water that's actually infiltrated through our sample. And so this shows the benefits when we have a good canopy, we have a lot of plants growing, we almost have a full container here of water that's infiltrated as we put on the same amount of water versus only about 2/3 fill here where we didn't have the actual plants growing there, so we had less ability for those plants to be able to hold that water there and let it soak in, and so it ran off. And this one isn't quite as convenient as the other one when it comes to a classroom activity, but it can still be used in the classroom, but like Gary had mentioned, it is twice as big as our other version, and so it helps in some cases to be able to have taller forage that you could be able to use in the simulation. And you can still use it in the classroom, it's just a little bulkier, not quite as easy to move around.